Check this out. This is currently one of the most popular dash cams in America. It's the #2 bestseller on Amazon, and over 10,000 people took the plunge just last month. Today, we're going beyond the Amazon reviews. Numbers tell one story, but real-world testing often tells another. We're putting this hardware to the test to see how those specifications translate into actual image quality. We'll be analyzing its true resolution, the effectiveness of its HDR, the intelligence of its 3DNR noise reduction, and taking a look at its frame rate stability. Our reference point for today remains the VIOFO A229 Pro, widely considered the gold standard in dashcam performance. By placing the Newcomer right next to our benchmark, we can see exactly where the hardware stands. For HDR, 3DNR, and frame rate tests, we follow a strict identical protocol. Same time, same environment, same light source, and the exact same height and distance. All right, everyone, focus your eyes on the center of the screen. Theoretically, a true 4K sensor should keep these lines tack sharp all the way down to the 18 mark, or even higher. But look closer, right here. Between the 12 and 14 marks, the lines completely blur and merge together. They merge together like overcooked noodles. This means the hardware's physical resolving power is actually at a 2K level. While the file output is 4K, the actual optical resolving power aligns more closely with 1440p standards. This is not 4K. This is 4K-ish. This is 2K hardware wearing a 4K oversized t-shirt. The file says 4K, but the image quality is 1440p. It's like buying a Ferrari and finding a lawnmower engine inside. So weak. Look at the A229 Pro, the golden child.
Nice.
Clear lines all the way to 20. Phooey-yo. That's the child your mom compares you to. Why you not sharp like A229? Why you so blurry? So while both boxes are plastered with the 4K label, one actually has the muscle to back it up, while the other is just there for participation points. Next, let's take a look at the HDR performance. This is where we see how these sensors handle challenging lighting in the real world. On top is the A229 Pro as a reference, and on the bottom is the D016. Look at the A229 Pro on top. So clean. You can see every digit. Now look at our $100 Budget King D016. Hey, look at that glare. The last digit, the number 7, is completely gone. It didn't just blur, it evaporated. Imagine a hit and run at night. The officer asks for the license plate, and all you can do is point at the screen and say, "Officer, this digit has achieved enlightenment." Real HDR isn't just a software filter. It requires the sensor to capture multiple exposures simultaneously, one for the bright highlights and one for the dark shadows. The A229 Pro uses Sony's Starvis 2 tech, which has a massive dynamic range. The D016, however, seems to be struggling with a standard sensor that's being pushed past its physical limits. When the sensor gets overwhelmed by light, the pixels bleed into each other. That's why the number 7 doesn't just look blurry, it literally vanishes into the white glow. The core value of a 4K dashcam is that single frame of clarity when you need it most. In this test, the target is stationary, and the lighting is controlled, representing a near-ideal scenario. Since we're seeing the D016 reach its processing limits here, it raises a practical concern. In a real-world scenario with flickering streetlights and a car zooming past at 60 miles per hour, the stress on the sensor will be far greater. That missing 7 is a crucial reminder. Once high-frequency details are lost to highlight clipping, they are generally unrecoverable in post-production. This illustrates the practical ceiling of a sensor's dynamic range. While the box says 4K, the real-world performance is ultimately determined by how the hardware manages light and resolving power under pressure. While we're at it, let's take a quick look at the viewing angles. The A229 Pro claims 140 degrees. The D016 claims 170 degrees. But here's the plot twist. The 170-degree shot actually looks narrower than the 140-degree one. This is what I call mathematical creative writing, using diagonal field of view, DFOV, as a marketing gimmick. It's a solid reminder that on-paper specs are like Tinder photos. They're for reference only. Don't fall in love at first sight. Next up, let's talk about 3DNR. Think of 3DNR as the digital cleanup crew that scrubs away the messy static from your night footage. It's the difference between a grainy home movie and a clean cinematic shot. On the D016, what are all these dancing pixels? It looks like a disco party in the shadows. Hiya, so much noise. The algorithm is struggling so hard, it's sweating. The A229 Pro? Smooth, stable, like a professional butler. The D016? It's like a drunk cleaner who missed all the corners. Why is it called 3D NR? Because it adds the dimension of time. A basic 2D filter only looks at one frame at a time, but 3D NR compares multiple frames. It says, hey, that grain of sand moved in the last 3 frames, but the license plate didn't. That sand must be noise. This requires massive brain power from the ISP. When the hardware can't keep up, the noise stays, and the details get swallowed by the static. Ultimately, it's not about labeling one device as good and the other as bad. It's about understanding the hardware's performance envelope. When selecting a dash cam, you're investing in more than just a pixel count. You're investing in computational overhead. For users who prioritize high-fidelity evidence in challenging low-light conditions, that extra processing capability transitions from a premium feature to a critical requirement. Finally, we come to the most technical part of the test: frame rate. Some budget 4K cams use a trick called frame repeating to inflate their numbers. They claim to record at 30 frames per second, but in reality, the hardware might only be capturing 20 or 24, and then copy-pasting the same frame multiple times to fill the gap. I've lined up both clips on the timeline for a side-by-side comparison. We're going to use the most direct and rigorous method possible, a frame-by-frame analysis. All right, let's begin. Watch closely right here. There it is. The D016 has a repeated frame. The image is completely frozen. Let's keep moving, and there's another one. To be honest, frame repeating is incredibly hard to spot during normal playback, but it's actually a rhythmic pattern of missing data. This means that for a significant portion of every second, the D016 is effectively blind. These invisible gaps are what matter most during a critical moment. Now that you've seen how this works, check your footage to see how your device handles high bitrate processing. In our tests, we noticed instances where the hardware struggles to keep up, leading to these repeated frames. If you're driving at 60 miles per hour and this camera blinks, you just missed 3 meters of evidence. This camera is like a witness who says, "I saw the accident." Oh wait, my eyes were closed for that part. My bad. Frame repeating is a common technical compromise in budget-friendly hardware. It allows a device to output a 4K file even when the processor reaches its limits at 30 frames per second. While it looks smooth on a small smartphone screen, this lack of unique data between frames could impact the reliability of the footage when used as critical evidence. All right, everyone, that wraps up our imaging tests for the D016. To make things clearer, I've summarized its performance in this table. The results indicate that the resolution reaches the 2K level, HDR struggling with glare, and 3DNR leaving visible noise. The duplicate frame rate is about 20%. Beyond what we can see with our eyes, I also pulled the raw file data and ran it through MediaInfo by media area. This industry-standard tool lets us look past the 4K label and see what's actually happening inside the metadata. The data doesn't lie. Interestingly, the specific frame rate isn't explicitly detailed on the packaging. Our MediaInfo analysis fills in those blanks, showing a consistent 25 frames per second, which is an important technical detail for users to be aware of. Even more critical are these 2 conformance errors. The internal chip is screaming for help. It's trying so hard to pretend it's 4K that it's literally breaking apart. Combined with low complexity encoding and mono audio, it's clear the internal silicon is being pushed to its absolute physical limits to save on costs. We need to make one thing clear. Comparing a $100 device to the industry benchmark, a 229 Pro, is inherently an upward challenge. The D016 lowers the barrier for the 4K concept, but under extreme physical limits, the hardware cost constraints are obvious. It wasn't designed for professional forensics, but for budget-conscious users who just need basic coverage. Next episode, I'm getting my screwdrivers out. We're going to open this thing up and see what's inside. Is it a real processor or just a piece of ginger? I'll see you in the next one.